Hey everyone. Tonight we're going to drift slowly through the history of operating systems. So dim the lights, maybe turn the brightness down a little, and settle in. This is one of those histories that sounds technical, but actually ends up being mostly about tired engineers, extremely large machines, and people trying very hard not to waste expensive computer time. Because early computers were not friendly, they were not personal, and they definitely were not multitasking. They were more like very expensive, very dramatic calculators that demanded full attention and then still made you wait. So tonight we'll just glide through how those machines slowly evolved into the calm, invisible operating systems we live inside today. And we'll take it slowly, no rush, no suspense, just one step, then another. By the way, if you're enjoying this content, would you mind hitting the like and subscribe button? This helps create more content like this. Thank you. In the very beginning, there were no operating systems at all, which sounds almost peaceful, but it really wasn't. Early computers in the 1940s and early 1950s were programmed by physically rewiring them, not metaphorically, literally rewiring them. You'd plug cables into panels, flip switches, maybe load punched cards, and hope nothing exploded. Well, not exploded exactly, but things did break, a lot. Every program had to take complete control of the machine. There was no layer in between. No file system, no scheduler, no helpful interface. Just raw hardware and a very patient human. And these machines were enormous. Entire rooms, sometimes entire floors. They hummed softly, like giant refrigerators, except much more expensive and much more fragile. If you wanted to run a calculation, you'd procure a stack of punched cards. Each card represented a line of instructions. Drop one card, and your program was now slightly different, which must have been calming in a very stressful way. The computer operators became a special kind of person, quiet, methodical, careful with stacks of paper, probably not rushing anywhere. They would load jobs one at a time, wait, collect the output, then load the next one. No multitasking, no background processes, just one job, then another. It was very linear, almost meditative, but also incredibly inefficient, because computers were expensive and humans were slow. So engineers started thinking, what if we let the machine handle some of this automatically? And that idea very gently became the first operating systems. The earliest versions weren't really operating systems as we think of them today. They were more like small helper programs. They would sit in memory, quietly, waiting to load the next job, like a calm librarian moving one book after another. These were called batch systems. Instead of manually loading each program, you'd hand the computer a batch, a stack of jobs, and it would run them, one after another, without human involvement. This was considered extremely advanced. The computer could finally work alone for minutes at a time, sometimes even hours, which must have felt futuristic. These early systems were simple. They didn't multitask, they didn't prioritize, they just kept things moving. But the idea was important. There was now software controlling the computer itself, not just running on it, but managing it. That's the quiet birth of the operating system. No fanfare, no dramatic launch, just automation. By the late 1960s, computers were still huge, but they were becoming more common in universities and large companies. And people wanted something new. They didn't want to wait hours for their program to run. They wanted interaction. Which sounds obvious now, but at the time, it was ambitious. So engineers developed something called time sharing. Instead of running one program at a time, the computer would switch between many very quickly, giving each user a small slice of time. It created the illusion that multiple people were using the computer simultaneously. even though, under the hood, it was just switching very fast. This was a big conceptual shift. The operating system was no longer just loading jobs. It was orchestrating multiple users, quietly, carefully, without anyone noticing. It had to track memory, schedule tasks, prevent conflicts, and do it all without crashing, which it sometimes did, but still, progress. Let's slowly move over to another thread of the story, because while large institutions were experimenting with time sharing, something else was happening. Computers were shrinking, very slowly, but noticeably. And with smaller machines came a new idea, the personal computer. Though at first personal meant something like a single user in a lab. Still, it was a shift. These smaller machines needed simpler operating systems, not massive time-sharing environments, just something that could load programs, manage files, and stay out of the way. So early lightweight operating systems began to appear. They weren't glamorous. They didn't have graphics, just command lines, blinking cursors, and minimal instructions. You'd type a command, press enter, and wait. It was quiet computing, very direct, very minimal, and a little intimidating if you didn't know the commands. But for engineers, it was perfect, because they liked control. Meanwhile, large companies were building extremely serious operating systems, complex ones, massive ones. Some of them became almost legendary, not because users loved them, but because they were so complicated. These systems tried to do everything, manage multiple users, control hardware, schedule tasks, handle memory, provide security, and of course, complexity increased. Which meant bugs increased, which meant engineers worked late. There's a pattern forming here. Let's gently move into the late 1960s, which is where things start to resemble modern computing, just slightly. Researchers at Bell Labs were working on a project called Multics. It was ambitious, very ambitious. It aimed to create a fully interactive, multi-user, secure, time-sharing operating system. It was elegant, complex, and slow to complete. Some people liked it. Some people quietly drifted away. And among those who drifted away were a few engineers who decided to build something simpler. Because sometimes the calmest idea is just less. They wanted an operating system that was small, clean, and flexible. So they built one. It didn't look like much. It wasn't flashy. It wasn't trying to change the world, but it was elegant. Simple commands, modular design, text-based interaction, and it quietly became one of the most influential operating systems ever created. But we'll ease into that slowly in the next stretch. For now, just imagine a calm terminal window, a blinking cursor, and someone typing, carefully, one command at a time. No notifications, no pop-ups, just quiet control. And that's where we'll gently pause for now, as operating systems slowly begin to take shape.
There was a time, not very long ago, when computers did not run. They didn't boot. They didn't greet you with a desktop or a blinking cursor or even a quiet hum of readiness. They simply waited. They were enormous, patient things. Cold rooms filled with cabinets and cables, glowing tubes, and the slow turning of reels. Machines that felt less like tools and more like landscapes. You didn't sit down at them, you approached them. And when you approached, nothing happened. Because in those early days, a computer did not know how to begin. There was no operating system, no conductor, no caretaker, no intermediary between human intention and machine execution. If you wanted a computer to do something, anything, you had to speak directly to its raw circuitry. and that meant every step had to be prepared in advance. The earliest programmers didn't open programs. They constructed them, piece by piece, like watchmakers assembling delicate mechanical time. Instructions were punched into cards. Each card held a single line. A stack of cards became a program, and a program became a request, a whisper offered to a machine that might, if everything aligned, respond. But the machine itself did nothing to help. There was no memory of previous work, no environment waiting, no system quietly managing resources. Every time someone wanted to run something new, the computer had to be manually reset, its switches flipped, its state cleared, its very personality erased. It was like waking a giant, asking one question, then putting it back to sleep, over and over again. The people who worked with these machines began to notice something strange. The computer, the only advanced device humanity had ever created, spent most of its life doing nothing. Waiting for cards, waiting for setup, waiting for humans to prepare the next task. The machine was fast, blindingly fast for its time, but the process around it was slow, painfully slow, human slow. Hours of preparation for minutes of computation. It felt wrong. There was something almost tragic about it. This brilliant electronic mind idling in silence while humans shuffled paper and rewired panels. Some of the early engineers described the feeling as waste. Others described it as inefficiency. But a few began to see it differently. They saw potential. They imagined a machine that didn't sleep between tasks. A machine that remembered how to begin. A machine that could prepare itself. A companion, not just a calculator. The idea formed slowly. What if the computer could handle the boring parts? What if it could load the next program automatically? What if it could remember where things were stored? What if it could manage its own memory? What if it could mediate between multiple requests? These were radical thoughts. At the time, computers were not seen as autonomous. They were obedient, completely passive. The notion that the machine itself might manage work felt almost philosophical. It meant giving the computer a kind of responsibility, a quiet intelligence that lived beneath the visible program, something that wasn't the user's code, something that wasn't hardware, something in between. But before that idea could take shape, there was frustration. The frustration of wasted time, the frustration of missed opportunities, the frustration of knowing that the machine could do more if only it didn't need humans for every tiny step. Imagine sitting in a dimly lit lab in the 1950s. The air smells faintly of warm electronics. A printer chatters occasionally. Someone carefully feeds a stack of cards into a reader. The machine processes them, then stops. Now everyone waits. Someone removes the output. Another person prepares the next stack. Someone flips switches. Someone resets memory. Minutes pass. The machine sits idle. You watch the lights flicker faintly, like a sleeping creature. And you think, why can't it just continue? This was the first emotional spark behind operating systems. Not ambition, not abstraction, not theory, but impatience. Humans had built something powerful, and it felt constrained. They wanted the machine to flow from one thought to the next, like a mind. They wanted continuity. They wanted the computer to feel alive. The earliest experiments were simple. Engineers began creating tiny programs that did nothing but prepare the next program. They weren't called operating systems yet. They were called monitors, supervisors, loaders, small bits of code that lived at the edge of execution. They would load a program,
run it, clean up memory, load the next one. It sounds trivial now, but at the time it was revolutionary. The computer was no longer just executing instructions, it was managing them. It was becoming aware of sequence, aware of order, aware of workflow. The machine was learning to organize. And something subtle changed. The computer was no longer just a device that answered questions. It became a stage where multiple ideas could appear one after another. Programs became guests. The machine became the host. This invisible host, this quiet orchestrator, was the earliest ancestor of the operating system. It had no interface, no personality, no name, but it carried a profound idea. The computer could take care of itself, so humans could focus on dreaming. In those early rooms, surrounded by humming hardware and stacks of cards, a new concept was being born. Not loudly, not dramatically, but gently. The idea that a computer should welcome work, that it should prepare itself, that it should mediate between human wishes and machine execution. A quiet caretaker, an invisible companion, a digital steward. The operating system had not yet fully arrived, but its spirit was already there, waiting just beneath the surface. And humanity, without fully realizing it, had begun creating something deeper than software. They had begun creating a partner for thought.
So we left things in the late 1960s. Large computers, complicated operating systems, and a few engineers quietly drifting away from something too ambitious. Multics had grand plans. It wanted to be everything. Secure, multi-user, modular, powerful. And understandably, it took a long time. Some of the people working on it began to feel a little tired. Not dramatically tired, just the calm kind. The kind where you quietly decide, maybe we should try something simpler. And that's exactly what happened. At Bell Labs, a small group began building a new operating system. Not huge, not flashy, just clean. They wrote it for a modest computer, nothing particularly impressive, which in a way made the project feel even more relaxed. The goal wasn't domination, it was usability. The system had a simple philosophy: do one thing, do it well. Then connect small things together. That idea sounds obvious now, but at the time it was refreshing. Instead of giant monolithic systems, they built small tools. Each tool handled one task. Then users could combine them, almost like stacking quiet little building blocks. The operating system became known as UNIX, and it spread, slowly, quietly, almost accidentally. UNIX had a personality. It was text-based, minimal, almost stubbornly simple. You typed commands, it responded. No icons, no windows, just text, which made it perfect for engineers and slightly confusing for everyone else. But it had something special. It was flexible. You could pipe the output of one program into another, chain commands together, build workflows. It felt elegant. And because it was written in a portable language, it could run on different machines. That was new. Operating systems used to be tightly bound to hardware. Now they could travel, which meant Unix began appearing in universities, research labs, quiet corners of computing. Students learned it, modified it, extended it, and like many calm revolutions, it spread without much noise. Let's gently shift to another parallel development. While Unix was growing in academic spaces, something else was happening. Microcomputers were emerging, smaller machines, cheaper machines, machines that individuals could own. This was the 1970s, and suddenly computers were not just for corporations anymore. They were still somewhat intimidating, but they were accessible. And these microcomputers needed operating systems. Not massive time-sharing systems, not research tools, just something simple. So lightweight disk operating systems appeared. They loaded from floppy disks, they managed files, they launched programs. That was enough. These systems were minimal. You turned on the computer and saw a blinking cursor. It was quiet, direct, no distractions. You typed commands like load, run, dir, short, functional, almost meditative. But these systems had limitations. They usually handled one program at a time. No multitasking, no memory protection. If something crashed, everything crashed, which happened occasionally, but users didn't seem to mind. They were just happy to have computers at all. Let's click on over to another slow development. As personal computers became more popular, people wanted friendlier interfaces. Not everyone loved typing commands, some preferred visuals, which led to early graphical experiments. These were primitive, blocky icons, simple windows, limited interaction. But they introduced a new idea. The operating system could be seen, not just typed. You could point, click, move things. It felt different, calmer in some ways, more approachable, but also heavier. Graphics required more memory, more processing power, so early graphical systems were often slow, deliberately slow. Windows moved gently, menus appeared gradually, everything had a soft pace, which in hindsight feels oddly appropriate. Meanwhile, UNIX continued evolving quietly. Different versions appeared, different institutions modified it. Some focused on research, some on stability, some on networking. Networking became important because computers were starting to connect. At first, just small local networks, machines in the same building. They shared files, shared printers, shared workloads. Operating systems had to manage this. They needed permissions, user accounts, security. UNIX handled this elegantly, which made it popular for servers long before people called them servers. These machines sat quietly in rooms, running continuously, serving files, managing access, rarely touched. They were calm, persistent, dependable. Let's drift slowly into the early 1980s. Personal computers were becoming more standardized. Companies wanted consistent platforms, and operating systems became more formal products. Instead of hobbyist tools, they were packaged, documented, sold. Users installed them from disks, configured settings, learned commands. These systems still used text interfaces, mostly, but graphical ideas were gaining traction. Some machines experimented with mice, others with overlapping windows. It was a gentle transition. Nothing changed overnight. Users moved gradually from typing everything to clicking some things and typing the rest. Operating systems became hybrids, part command line, part graphical, and this dual nature would persist for decades. At the same time, multitasking became more important. Users wanted to run more than one program, edit text while printing, while copying files. Operating systems began scheduling tasks, switching between them. This wasn't always smooth. Sometimes the system paused, sometimes it froze briefly, but the idea worked. Multiple processes sharing one machine. The operating system became a quiet coordinator, balancing everything behind the scenes. Users rarely thought about it, which is usually the sign of good design. Let's gently settle into one more thread. As operating systems matured, they became more layered. Hardware at the bottom, kernel in the middle, user programs on top. The kernel handled core tasks, memory management, scheduling, device control. It stayed hidden. Most users never saw it, but it was always there, quietly working. This structure allowed systems to grow without chaos. New features could be added without rewriting everything. Operating systems became stable platforms rather than experimental tools, which felt reassuring. By the mid-1980s, the concept of an operating system was firmly established. Every computer had one. It loaded automatically, it managed hardware, it ran programs. Users no longer thought about how computers worked without one, because that era was fading. Operating systems became invisible infrastructure, quiet, dependable, always present. And from here, things would begin to branch further. Graphical systems would expand, networking would explode, personal computing would grow. But we'll ease into that slowly next. For now, just imagine a simple desktop, a few icons, a calm blinking cursor, and an operating system quietly doing its job without asking for attention.
In the beginning, the computer didn't know how to move from one idea to the next. Each program was an isolated moment, a single breath, a lone spark in the dark. But humans don't think that way. We move from thought to thought, building, layering, remembering. We don't want to restart our minds every time we solve a problem. And slowly, quietly, engineers began wanting the same thing for machines. They wanted continuity. The first attempt at this continuity was simple. Instead of feeding one program at a time, operators began stacking them. Dozens of punched card decks, one after another, each belonging to a different researcher, a different idea, a different dream. The stack became known as a batch, and the idea was elegant in its simplicity. Let the machine run them all without stopping. No resets, no manual intervention, no silence between thoughts. Just one long flow. But there was a problem. Computers didn't understand where one program ended and another began. To the machine, it was just a river of instructions. Without guidance, everything blurred together. So, engineers added control cards. These were special instructions that didn't belong to the user's program. They belonged to the system, the caretaker. They told the machine, here is a new job. Load this program. Print this output. Clear memory. Move to the next. It was primitive, but it was the first time the computer was given a sense of order. The first time it could recognize boundaries. The first time it could transition. Imagine the moment this worked for the first time. A stack of programs loaded into the reader. The machine begins. Lights flicker, relays click, paper advances. One program finishes, and instead of stopping, the machine continues. It loads the next one without a human touching it, without a reset, without waiting. Just continuation. To modernize, this seems trivial, but to the people watching, it felt like the machine had taken a step toward independence. The computer was no longer waiting for humans to guide every motion. It had learned to carry on. These early batch systems were crude. If one program crashed, the entire batch might fail. If a card was mispunched, hours of work could be lost. There were no safeguards, no protection. But still, something beautiful had emerged. The idea that the computer could shepherd work. Programs were no longer lonely. They traveled together. One researcher's physics calculation, followed by another's payroll routine, followed by a student's experimental algorithm. Different minds, different purposes, all sharing the same machine. The computer had become a shared dream space. This created a new emotional shift. Before, using a computer felt like borrowing a sacred artifact. You prepared carefully. You waited your turn. You hoped nothing went wrong. Now you submitted your stack and walked away. The machine would take care of it. There was trust forming, a subtle relationship. Humans were beginning to delegate responsibility to software. But batch systems also revealed a deeper problem. Programs spent much of their time waiting. Waiting for input, waiting for output, waiting for slow printers, waiting for tape drives. And during that waiting, the CPU sat idle. Again, the same old inefficiency returned, just in a new form. The machine had learned continuity, but not awareness. It didn't yet know how to use its own time wisely. It was like a conductor who could cue musicians, but didn't yet know how to let another instrument play when one paused. This bothered engineers. They had solved one silence only to discover another. Some began imagining something more sophisticated. What if, when one program waited, another could run? What if the machine could switch between jobs? What if it could keep multiple ideas alive at once? This was a dangerous thought. It meant the machine would need memory management, protection, scheduling, priorities. It meant complexity, but it also meant something profound. The machine wouldn't just continue work, it would balance it, like a mind juggling thoughts, like a host attending many guests. Batch systems were the first caretakers. They didn't understand, they didn't adapt, they simply followed a script. But they introduced something new, the computer as a steward, a quiet figure behind the scenes, guiding programs forward, one after another through the long night of computation. And for the first time, the machine didn't feel like a tool waiting to be used. It felt like something that received your request, held it, and fulfilled it in its own time. A subtle companionship was forming. The operating system still had no name, but it had begun to watch over human intention. And the next step would make that watcher far more intelligent.
By the early 1990s, operating systems had settled into a comfortable rhythm. Graphical interfaces were common, multitasking existed, networking was slowly expanding. Computers still felt calm. Slow, but calm. You turned one on, waited, watched text scroll by, and eventually landed on a desktop. No notifications, no syncing, just a working environment. And while commercial systems were evolving, something quieter was happening in universities and bedrooms. Students were experimenting. Because operating systems, by this point, had become fascinating puzzles, large, complex, but understandable. And some people wanted to build their own. Not for profit, not for distribution, just curiosity. One such student started writing a small operating system kernel, mostly for fun. He wasn't trying to change the world. He just wanted something that behaved like UNIX on a personal computer, which at the time wasn't easy. So he wrote it piece by piece, keyboard handling, memory management, process scheduling, slowly, calmly. He posted updates online almost casually, asking if anyone was interested. Some people were. They downloaded it, tested it, sent suggestions. It grew quietly. More contributors appeared, more features were added. And this small hobby project gradually became a real operating system. Not flashy, not polished, but functional. And most importantly, open. Anyone could see the code, modify it, improve it. This collaborative style felt different. Less corporate, more communal. People worked on it at night, after classes, during quiet afternoons. It spread slowly. Servers began using it, developers experimented with it, universities adopted it. It wasn't dominant, but it was steady, and that steadiness mattered. Let's gently shift to another development happening at the same time, the Internet. In the early 1990s, networking transformed from local connections into something broader. Computers connected across cities, then countries, then, quietly, the world. Operating systems had to adapt. They needed TCP/IP stacks, network configuration tools, remote login support. These features became standard. You could connect to another machine miles away and work as if you were there. Text flowed slowly across terminals. Commands executed remotely. It felt almost magical, but still subdued. No graphics, just calm text. Graphical systems also began incorporating networking. File sharing expanded, remote printing improved. Email clients appeared. Operating systems started managing connectivity automatically. You plugged into a network and things just worked. Sometimes. Other times you adjusted settings manually and tried again. Still, progress. Meanwhile, hardware improved again. Faster processors, more RAM, better storage. Operating systems used these resources to become smoother. Animations improved, multitasking felt more responsive, applications opened faster. Not instant, but noticeably quicker. Users grew accustomed to this. Waiting became shorter. Interaction felt more fluid. Operating systems remained calm, but more capable. Let's drift toward user experience. Designers began thinking carefully about layout, consistency, visual clarity. Menus were standardized, buttons placed thoughtfully, dialogues simplified. Operating systems guided users gently. You clicked Open, and a familiar window appeared. You clicked Save, and another predictable dialogue showed up. It removed uncertainty. Computing felt safer. You knew what would happen. Another quiet innovation, background updates. Operating systems started improving themselves occasionally. Small patches, bug fixes, driver improvements. Users installed updates, sometimes manually, sometimes automatically. The system evolved without being replaced entirely. This incremental change became normal. You didn't buy a new OS every year. It just improved, slowly. Let's slide into multimedia, which began expanding in the mid-1990s. Sound support improved, video playback appeared, basic media players became common. Operating systems handled audio devices, video drivers, codecs. These features added richness, but kept the same calm foundation. You opened a sound file, and it played. You opened video, and it ran, gently. No streaming yet, just local files. Quiet playback. Portable computing also advanced. Laptops became lighter, battery life improved. Operating systems added sleep modes, hibernate, power profiles. You closed the lid, and the machine rested. Opened it, and resumed. It felt natural. Computers adapted to human rhythm, not the other way around. Let's move gently toward stability. Earlier systems sometimes crashed entirely. Now, operating systems isolated failures. An application froze, but the system stayed alive. You closed the program and continued working. This resilience became expected. Operating systems matured. They handled errors gracefully, which made computing less tense. Another subtle development, file systems improved. Earlier storage systems were simple, limited naming, basic structure. New file systems added long namings, permissions, metadata. You could organize documents better, search more easily. Operating systems managed this quietly. Folders nested deeper, files grew larger. Everything scaled. Meanwhile, command lines remained. Power users still relied on them. Scripting emerged. You could automate tasks, copy files, process text, schedule jobs. Operating systems executed scripts silently. Work happened in the background. This blending of automation and interaction became powerful, but still understated. By the late 1990s, operating systems had become sophisticated environments. Graphical interfaces, networking, multitasking, stability, multimedia, all working together. And yet, they remained mostly invisible. Users launched programs, browsed aisles, connected to networks. The operating system orchestrated everything. Quietly, always present, rarely noticed. From here, another shift would begin. The web would expand, open-source systems would grow stronger, desktop environments would become more polished. But we'll ease into that gradually next. For now, imagine a mid-1990s desktop. Muted colors, a few icons, maybe a media player open. And underneath it all, the operating system, calmly holding everything together. By the mid to late 1990s, something subtle began shifting. Computers were no longer just standalone machines. They were becoming windows. Not metaphorically at first, quite literally. You opened a browser, and suddenly your computer felt bigger than itself. Pages loaded slowly. Images appeared line by line. Text filled in gradually. And the operating system sat underneath it all, calmly managing the experience. This was new. Before, the operating system was the main environment. Now it was becoming a platform for something else, the web. Users spent more time inside browsers, less time navigating files, less time launching standalone programs. Operating systems noticed this change. They began optimizing networking, improving TCP/IP stacks, handling multiple connections, because web browsing wasn't just one task. It involved dozens of tiny requests, images, fonts, scripts, documents. The operating system quietly coordinated them. It scheduled threads, managed memory, handled disk caching, all so a simple web page could load smoothly, or at least smoother than before. Let's drift gently into desktop design. As web usage grew, operating systems simplified their interfaces. Users didn't need dozens of utilities. They needed a browser, a file explorer, maybe email. So desktops became cleaner. Icons reduced, menus streamlined, colors softened. Some systems introduced taskbars. Others improved dock-style launchers. You clicked once, and your browser opened. Then you stayed there for hours. The operating system faded into the background, which, in a way, was success. Meanwhile, multitasking became more important. Users now browsed the web, downloaded files, played music, typed documents, all at once. Operating systems improved scheduling. Programs ran concurrently without slowing everything to a crawl. Audio continued while pages loaded. Downloads continued while you typed. It felt fluid, still calm, but more alive. Let's slide into hardware again. Processors crossed new thresholds. Memory became more affordable. Operating systems used extra RAM for caching. Recently opened files loaded instantly. Browsers reopened faster. Disk access decreased. Responsiveness improved. Users noticed this, even if they didn't understand why. Computers felt less sluggish, more cooperative. Another quiet development, plug-and-play hardware. Earlier systems required manual configuration. You installed the device and then adjusted settings. Now, operating systems began detecting hardware automatically. You plugged in a mouse. It worked. A printer, detected. A keyboard, instant. This simplicity mattered. It reduced friction. Computers felt less technical, more approachable. Operating systems handled complexity silently. Let's gently transition into stability improvements again. With more users, crashes became unacceptable. Operating systems strengthened memory protection. Applications ran in isolated spaces. One crash didn't take down everything. You might see a frozen window, but the desktop remained. You closed the app and continued. This resilience built trust. Users relaxed. Computers felt dependable. Another slow change, software installation. Earlier, installing programs meant copying files manually. Now, installers appeared. You double-clicked, followed steps, and the program integrated itself. Operating systems tracked installed components, registered file types, updated menus. The process became guided, less guesswork, more predictability. Meanwhile, file systems evolved again. Search functions improved, sorting options expanded. You could find files by name, date, type. Operating systems indexed content quietly. Searching felt faster. Documents became easier to manage, especially as hard drives grew larger, because suddenly users had hundreds, then thousands of files. Organization mattered. Let's drift into laptops again. Portable computers were becoming common. Operating systems adapted further. Battery indicators improved. Sleep modes became reliable. Wireless networking began appearing. You opened a laptop, connected to a network, and browsed. No cables required. This felt futuristic, but also quiet. No fanfare, just convenience. Operating systems handled connection changes seamlessly. You unplugged and continued working. Meanwhile, audio and video improved again. Operating systems supported more formats. Music players became standard. Simple video playback matured. Users downloaded media from the web, stored it locally, and played it back. Operating systems balanced playback with multitasking. Music continued while browsing continued. Video played while downloads ran. This layering of tasks became normal. Let's move gently toward customization. Users wanted control. Operating systems allowed theme changes, wallpaper selection, icon arrangement, small adjustments but meaningful. You shaped the environment. It felt personal. Operating systems remembered preferences, restored layouts, maintained continuity. Another subtle development, system updates became more regular. Security patches, bug fixes, performance tweaks. Operating systems began notifying users. Updates installed, sometimes requiring restarts. This cycle became familiar. The system improved gradually. No dramatic changes, just quiet refinement. Meanwhile, developers built applications expecting modern OS features. They relied on multitasking, networking, graphics acceleration. Operating systems provided stable APIs. Software became richer, but also heavier. Operating systems compensated with better memory management, balancing resources carefully, keeping everything smooth. Let's ease into the early 2000s feeling, without rushing. Computers now felt complete. You powered on, logged in, opened a browser, checked email, played music, typed notes, all within minutes. The operating system coordinated everything invisibly, which was the point. It became infrastructure, like electricity, always there, rarely noticed. Another quiet shift, user accounts. Operating systems separated users. Each person had their own files, settings, preferences. This mattered for families, offices, shared machines. Switching users became simple. The system maintained isolation. Security improved. Personalization deepened. Networking matured further. File sharing across home networks became common. You accessed another computer's files, sent documents to shared printers. Operating systems handled permissions, discovery, connections. This made multiple computers feel like one environment. Calm, connected, cooperative. Meanwhile, background services expanded again. Indexing, updates, networking. Tasks operating systems ran quietly. You didn't see them, but they improved responsiveness. Files appeared faster. Search worked instantly. Everything felt smoother. Let's drift toward the emotional tone of computing. Earlier computers demanded attention. Now they waited. They sat quietly, ready. You approached when needed. The operating system remained patient, always prepared, never dramatic. This calmness defined the era. Soon, another transformation would begin. Mobile devices, touch interfaces, always connected systems. Operating systems would shrink, then expand again. But we'll move into that slowly next. For now, picture a quiet early 2000s desktop. A browser open, music playing softly, downloads finishing in the background, and underneath it all, the operating system doing its work without asking to be noticed.
By the late 2000s, the computing world began feeling smaller. Laptops were no longer the peak of portability. Smartphones and tablets emerged, gently reshaping expectations. Operating systems had to adjust. They were no longer just in desktops or laptops. They had to scale down, stay efficient, and remain patient. Mobile devices demanded instant responsiveness. Applications had to open quickly. Touch input required precision. Animations had to be smooth. Operating systems began supporting gestures, swipes, pinches, taps. The interface responded immediately without hesitation. Everything had to feel natural, like an extension of your hand. Meanwhile, connectivity became constant. Wi-Fi, cellular networks, and later 4G ensured that devices were always online. Operating systems silently managed data, syncing mail, calendars, and photos. Users didn't notice the background work. They only noticed that everything was ready always. The shift to mobility also brought power efficiency into focus. Operating systems learned to sleep components when idle. CPU cores shut down when unnecessary. Displays dimmed intelligently. Battery life improved, quietly but significantly. Let's drift into app ecosystems. Mobile operating systems created curated stores. Applications could be downloaded, updated, and installed with minimal effort. The operating system tracked permissions, it enforced rules, and it quietly maintained security. Users adapted. They didn't think about installation processes. They just tapped an icon, waited a moment, then used the application. This simplicity contrasted sharply with the slower, more manual desktop era. Operating systems now acted as invisible guardians, managing complexity so the user never had to. Another gentle evolution, notifications. Operating systems learned to communicate subtly. Alerts appeared briefly. Important updates persisted. Everything else remained in the background. It was a balancing act. Information flowed without being overwhelming. Users could remain calm while staying informed. Multitasking on mobile remained limited at first. Operating systems paused background apps efficiently. Memory was precious, so the OS prioritized the active application. Later, with more powerful hardware, multitasking improved. The system maintained performance silently. Let's click over to cloud integration. Operating systems began tying local devices to cloud storage. Documents saved automatically. Photos uploaded without prompting. Backups executed quietly. Data became device independent. Users could switch devices effortlessly. The OS handled the heavy lifting in the background. Meanwhile, updates became seamless. Mobile systems could update without rebooting or disrupting the user. Security patches applied automatically. Applications updated quietly. This created a sense of continuous improvement. The operating system felt alive, yet unobtrusive. Let's slide into customization. Even in mobile environments, users could adjust settings. Themes, wallpapers, icon arrangements. The operating system preserved these preferences. They remembered the user's choices across sessions. Another subtle improvement, gestures and haptic feedback. The system responded not just visually, but tactily. Vibrations acknowledged touches. This added a quiet layer of reassurance. The OS communicated gently, even physically. By the 2010s, operating systems had matured across devices. Desktops remained stable and productive. Laptops continued portability. Mobile devices introduced responsiveness, connectivity, and subtle interaction. The OS acted as the invisible foundation across all environments. It coordinated hardware, managed resources, ensured security, and maintained calm. Users began expecting systems to just work, instantly, efficiently, quietly. The operating system had become a patient companion, always present, rarely noticed, and essential. Soon, virtualization and cloud computing would introduce new layers. Operating systems would manage virtual machines, containers, and distributed networks. But for now, the era of quiet, responsive, mobile-aware systems had fully arrived. Computers had become gentle, patient, and reliable. And we had reached a point where the OS wasn't a thing to learn or command. It was simply a presence, orchestrating the digital world, softly, patiently, always waiting.
As the 2010s progressed, operating systems faced another quiet revolution. This time, it wasn't about flashy interfaces or touch gestures. It was about scale, flexibility, and managing complexity behind the scenes. Virtualization became increasingly important. The idea was simple. A single machine could act like many. Multiple virtual computers could run on one physical device, each isolated, independent, and self-contained. The OS handled the allocation of resources, memory, CPU, storage, all carefully divvied up. Users rarely noticed. They just saw their programs running smoothly. Servers adopted this as well. Data centers began running hundreds, sometimes thousands of virtual machines on single racks. Operating systems quietly orchestrated everything. Load balancing, fault tolerance, and scheduling were invisible to the end user. Yet, without the OS, nothing would function. Meanwhile, the cloud reshaped the landscape entirely. Computers were no longer limited by local hardware. Storage, computing power, and services existed remotely. Operating systems adapted to these changes. They integrated cloud accounts, synchronized data, and enabled remote access. Files you saved on one device appeared automatically on another. Music, photos, and documents were accessible everywhere. For the user, this felt seamless. The OS handled authentication, encryption, and syncing quietly. You didn't see the complex orchestration happening behind the scenes. It just worked. Instantly. Let's gently wander into containers, a concept that grew out of virtualization. Containers allowed applications to run with their dependencies bundled neatly together. Operating systems now managed these lightweight environments. It ensured isolation while maximizing efficiency. Developers embraced this. Deployments became predictable. Scalability improved. Users didn't see containers directly,
They only saw reliable applications that behaved consistently across devices. Once again, the OS stayed quietly essential, orchestrating invisible work. By this point, security had matured substantially. The rise of the Internet, always connected devices, and cloud services introduced persistent risks. Operating systems strengthened defenses. Permissions became finer-grained. Firewalls and sandboxing became standard. Automatic updates ensured vulnerabilities were patched quickly. The system constantly monitored itself, silently defending against threats. Users might notice occasional prompts. Mostly, though, the OS protected them without fanfare. Trust in computing grew because systems felt stable and reliable. Another quiet evolution was power management. As laptops, tablets, and hybrid devices became dominant, battery life was crucial. Operating systems became adept at monitoring energy consumption. Idle processes slowed. Background tasks deferred. Displays dimmed automatically. The user rarely had to intervene, yet the system stretched the battery to its maximum potential. Let's drift into user experience. By the mid-2010s, the expectation of continuity became universal. Switching between devices was expected to be seamless. Operating systems remembered sessions. Tabs, documents, and open applications synchronized across multiple devices. A user could start typing an email on a laptop and finish it on a phone. The OS maintained state, tracked progress, and handled conflicts. For the user, it felt natural, magical almost, yet entirely grounded in meticulous orchestration. Meanwhile, interfaces continued to evolve, but subtly. Design trends favored minimalism. Animations remained gentle. Notifications were non-intrusive. Colors softened. Transitions eased users from one task to the next. The OS orchestrated this calm flow, making technology feel approachable and unobtrusive. Let's glide into app ecosystems again. Stores and marketplaces had matured. Operating systems now managed updates, permissions, and dependencies automatically. The user tapped an icon. The application installed itself. The OS verified its integrity. It configured the environment. And then it stepped back. Everything felt effortless. The complexity existed, but the user never needed to see it. The operating system acted like a quiet facilitator. Another quiet layer, telemetry and diagnostics. Operating systems monitored performance continuously. Resource usage, crash reports, compatibility issues. This data allowed developers to optimize software and hardware interactions. It also helped prevent problems before users noticed them. The OS became not just a platform, but an observer and guide, learning from activity, adapting, and improving silently. By the late 2010s, the distinction between devices blurred. Desktops, laptops, tablets, and phones shared ecosystems. Operating systems adapted fluidly to screens of varying sizes, input methods, and resolutions. They coordinated cloud access, security, performance, and user experience consistently. Users rarely thought about the OS directly. They simply experienced continuity, stability, and responsiveness. Computing felt natural, predictable, and gentle. The operating system had transformed once again, from a visible environment to an invisible essential orchestrator. It managed resources, secured data, synchronized devices, and facilitated human activity. And yet it did so quietly, patiently, always in the background. Soon, artificial intelligence, voice interfaces, and personal assistants would introduce another subtle layer. Operating systems would begin anticipating user needs before they were expressed. But for now, the era of seamless virtualization, cloud integration, and always-on reliability had fully arrived. Users could relax, knowing their machines quietly managed the complexities, letting them focus on whatever task they chose or even nothing at all. By the early 2020s, operating systems had quietly settled into a rhythm. They were stable, reliable, and deeply integrated across devices. But a new layer began to appear, subtle, almost invisible, yet increasingly present. Artificial intelligence started to weave itself into the OS. It learned patterns of use. It suggested actions. It predicted needs. This wasn't science fiction. It was gentle, practical, and mostly unnoticeable until you noticed how much easier life had become. Voice interfaces became common. The OS could understand spoken commands. You could dictate a message, ask a question, launch an application, and the system responded patiently with minimal friction. These features required constant background processing. Natural language understanding, speech recognition, and contextual awareness ran silently. Users didn't see the complexity. They only saw the result. The experience was calm, responsive, and quietly impressive. Meanwhile, automation expanded. Tasks that once required manual intervention now happened without a thought. Backups, software updates, device syncing, and even simple optimizations occurred automatically. The OS orchestrated these quietly, ensuring that performance remained smooth. Notifications became smarter. Instead of alerting you constantly, the system learned when interruptions were least disruptive. They appeared gently, faded quickly, or waited until you were idle. This subtlety reinforced the sense of calm. Let's glide toward resource management. With AI-driven processing, operating systems began prioritizing intelligently. Background applications received processing power as needed. Energy efficiency improved further. Heat was managed proactively, and devices felt responsive, even under heavy multitasking. This kind of orchestration relied on a deep understanding of both hardware and user behavior. The OS became less of a static environment and more of a dynamic partner. It watched, adapted, and responded quietly. Cloud integration deepened. AI-assisted syncing, predictive caching, and content preloading became common. Documents you hadn't even opened yet could be ready before you requested them. Photos were organized automatically. Applications suggested the next step. The operating system anticipated your intentions without forcing them. It remained patient, unobtrusive, yet increasingly intelligent. Security also evolved alongside these changes. AI helped detect anomalies in behavior, flagging suspicious activity. Permissions became context-aware. The OS could intervene gently, without alarming the user unnecessarily. Systems felt safer, quietly defending against threats in real time. Let's shift to user interfaces. Designs became adaptive. Screens adjusted brightness and contrast based on ambient light. Colors and layouts shifted depending on task or time of day. Animations remained smooth and subtle. The OS learned to provide a sense of calm continuity. No jarring transitions, no sudden surprises, just quiet guidance and soft responsiveness. Another innovation, cross-device continuity. You started an email on your phone. You finished it on your laptop. You reviewed it later on a tablet. The OS ensured state preservation. Applications were aware of context across devices. The experience felt seamless, almost magical. And yet, it was entirely grounded in careful orchestration by the operating system. AI also touched accessibility. Operating systems could read text aloud, describe images, assist users with limited mobility. These features worked quietly in the background, enhancing usability without demanding attention. For many, the OS had become a silent helper. It learned preferences, adapted to routines, and made technology feel less like a tool and more like an extension of the self. Meanwhile, virtualization and cloud orchestration reached new heights. Operating systems managed distributed workloads across multiple machines, both local and remote. Containers, virtual machines, and serverless functions became routine. Users remained blissfully unaware of this complexity. Applications just ran. Resources were allocated seamlessly. By now, the operating system's role was deeply anticipatory. It predicted updates, suggested corrections, prepared resources, managed connectivity, handled errors silently. This invisibility became its hallmark. The OS was no longer something you interacted with directly. It was the silent stage upon which all computing unfolded. As devices continued to evolve, so did the OS. Touch, voice, AI, cloud, and predictive capabilities merged into a single, quiet ecosystem. From desktops to phones, from tablets to wearables, the system adapted, anticipated, and responded. Users rarely needed to intervene. Everything simply worked, calmly, consistently. And yet, behind the scenes, the operating system was awake, watching, learning, coordinating, ensuring that whatever the device, whatever the task, the experience remained smooth, predictable, and quietly satisfying. This was the era of anticipatory computing. The operating system had become less of a tool and more of an ever-present companion. Patient, reliable, unobtrusive. It shaped the digital world softly, steadily, without anyone noticing, until suddenly you realized how indispensable it had become. Soon, new paradigms, AI-generated interfaces, voice-first interactions, and even more immersive experiences would arrive. But for now, the operating system had achieved a kind of quiet perfection, a seamless, patient, and invisible presence, guiding users gently through the digital landscape. As we continue drifting through the story of operating systems, let's take a moment to look at the horizon. By the mid-2020s, OS development had become less about flashy features and more about subtle, integrated intelligence. The next frontier was augmented reality and edge computing, quietly reshaping how systems anticipate and respond. Augmented reality, or AR, isn't just about fancy overlays or immersive gaming. It's about context. Your device can now interpret the physical world and respond seamlessly. Directions appear steadily, notifications float where you need them, and information is presented without interrupting your flow. The operating system orchestrates all of this quietly, ensuring that interaction feels natural, effortless, and calm. Edge computing plays a key role. Instead of sending every request to the cloud, computation occurs closer to the user. Devices handle processing locally, reducing latency. Actions happen almost instantly. AI models run on device, anticipating your next move. The experience is smooth, responsive, and largely invisible to the user. This combination of AR and edge computing transforms the operating system into something more proactive. It doesn't just react to your commands. It suggests, preloads, and prepares. It reduces friction. It makes the digital and physical worlds feel like a single, continuous experience. Let's wander over to user privacy and control. Even with predictive AI and seamless cloud integration, users retain a sense of autonomy. Settings are adaptive but transparent. Permissions adjust contextually. The system nudges gently rather than forcing decisions. You feel in control yet supported. Security remains embedded in the OS's intelligence. AI detects anomalies in real time. It protects data quietly, anticipating threats before they become problems. The experience remains calm, safe, and mostly invisible. Accessibility continues to evolve alongside these trends. Devices can now interpret gestures, voice, and even eye movements. Text is read aloud. Objects are described, and suggestions are offered proactively. The OS becomes a quiet companion for all users, helping without ever demanding attention. Let's meander into personalization again. The system continues to learn your preferences and habits. It adjusts brightness, color schemes, and notification timing. It optimizes for workflow, energy use, and even mental focus. Every interaction feels tailored, seamless, and patient. Applications, too, become anticipatory. They suggest content, prefetch resources, and adapt interfaces to your patterns. The OS orchestrates all of this quietly in the background. You experience calm, continuity, and efficiency without noticing the work happening behind the scenes. Cross-device continuity is even more refined. Your work, media, and communications flow effortlessly from phone to tablet to laptop to wearable device. The operating system maintains state, context, and priority across all devices. You never have to wonder where you left off. The experience is fluid, predictable, and quietly intelligent. Edge AI also enables subtle predictive assistance. Your OS now helps you manage tasks before you request it. Emails are drafted, reminders set, and workflows optimized. Applications and devices collaborate without interruption. You notice the ease, not the complexity. The operating system has grown into a silent orchestrator of a complex ecosystem. It balances AI, cloud services, hardware, edge computing, AR, and user behavior. It anticipates needs, protects data, and maintains smooth interaction across devices. It's calm, patient, and mostly invisible, always present, rarely noticed, but profoundly influential. Even as augmented reality, edge computing, and AI-first design continue to evolve, the core principle remains unchanged. The operating system is here to make technology seamless, predictable, and quietly supportive. It manages complexity gracefully. It anticipates needs without intruding. It integrates hardware, software, and cloud services intelligently. And above all, it ensures that every interaction is calm, consistent, and effortless. Looking forward, the future promises even more subtlety. Fully immersive interfaces, AI that predicts context before even a gesture is made, and ecosystems that adapt silently around us. Yet through it all, the operating system remains the quiet, patient foundation, the calm companion that shapes our digital experience without ever asking for attention. Next, we'll drift gently into the subtle ways these systems will anticipate human behavior, making computing almost invisible, while still profoundly intelligent, all in the same quietly patient rhythm we've been following.
As we drift further into the 2020s, operating systems continue to quietly evolve. The pace of change isn't about flashy visuals or dramatic shifts anymore. It's about integration, prediction, and anticipation. AI-driven features are no longer optional add-ons. They're deeply embedded. The OS can suggest the next step in workflow before you even think of it. It can reorder priorities. It can optimize energy, memory, and CPU use intelligently. It adapts silently, learning your patterns without ever intruding. Let's move gently into ecosystem integration. Devices are no longer isolated islands. Your phone, tablet, laptop, wearable devices, and even your smart home appliances communicate effortlessly.
The operating system orchestrates all of these interactions. Files transfer seamlessly, notifications propagate intelligently. Media streams without pause. Everything feels like a single, calm system. Even interactions that once felt complicated, like setting up a new device, are now smooth. Accounts, settings, and preferences transfer automatically. The OS quietly ensures consistency across devices without the user noticing the heavy lifting behind the scenes. Voice interaction has matured further. The OS understands context. It handles multiple requests in parallel. It recognizes natural language nuances. It remembers previous commands. You speak casually and the system adapts. It doesn't just react, it anticipates. Alongside voice, gestures continue to evolve. The OS now supports subtle multi-finger movements, long presses, and context-sensitive swipes. Touch interfaces feel fluid, precise, and patient. Cloud integration deepens with predictive caching and AI-assisted preloading. Documents, emails, and media are ready before you even request them. Applications learn patterns of use. Photos are auto-tagged. Videos and music are pre-buffered, all handled quietly, efficiently, and imperceptibly. Security remains central. The OS constantly monitors for anomalies and usage patterns. AI-assisted intrusion detection flags potential threats. Permissions are context-aware. Automatic updates patch vulnerabilities instantly. Everything runs without user intervention, maintaining trust and calm. Multitasking is seamless. Applications run efficiently in the background. Resources are allocated dynamically. The OS prioritizes active tasks while keeping secondary processes ready. It balances performance and battery life silently. Accessibility also grows more sophisticated. Text-to-speech, image descriptions, haptic feedback, and predictive assistance help users navigate devices effortlessly. The OS adapts to each user's needs subtly enhancing usability. Let's click over to personalization. The system learns your habits. It adjusts brightness, themes, and notifications based on time, location, and routine. The OS shapes your experience subtly, creating a calm, predictable environment. Even small details matter. Icons adjust, gestures remain intuitive, and transitions are fluid. Everything's designed to minimize friction. The system stays patient, unobtrusive, and supportive. Now let's consider emerging paradigms. AI-first interfaces, augmented reality, and seamless cross-device workflows hint at the next stage. The operating system must manage not just hardware, but experiences. It becomes a curator of attention, a predictor of needs, and a silent orchestrator of the digital world. Computing is less about commands and more about interaction, anticipation, and continuity. The OS is a quiet companion, ensuring that all interactions feel natural, effortless, and satisfying. Even as devices continue to diversify, foldables, wearables, and smart glasses, the operating system remains central. It adapts to new input methods. It ensures compatibility. It predicts user intent. It maintains calm continuity across increasingly complex systems. The role of the OS is now subtle yet indispensable. It is patient, reliable, and invisible. It coordinates hardware, software, cloud services, and AI seamlessly. Users experience smooth, predictable computing without ever seeing the complexity beneath all this. In essence, the operating system has evolved from a visible interface to a silent, intelligent orchestrator. It manages resources, anticipates needs, adapts to behavior, ensures security, and integrates devices and services. It works quietly, reliably, and with subtle foresight. Users don't need to think about it. They simply experience the results. The calm, responsive, always present companion that makes computing effortless, serene, and quietly satisfying. And so the story continues. The operating system grows more intelligent, more anticipatory, and more integrated. It quietly shapes the way we interact with technology, making life simpler, smoother, and just a little bit more gentle as we drift further into the future. Next, we'll explore how AI-first operating systems are beginning to anticipate human intent in ways that blur the line between tool and companion. But we'll take it slowly, because after all, patience is part of the charm of the operating system. As we settle into the mid-2020s, operating systems are quietly entering a new era. This is the age of AI-first computing. Not just reactive, not just adaptive, but anticipatory. These systems study your habits carefully, learning patterns without interrupting. They observe which apps you use at certain times. They notice when you start typing a message and predict the next words. They organize your files based on usage and context. It's subtle, almost invisible, yet it changes the way you interact with your devices. Voice interaction has grown more natural. The OS can follow complex multi-step instructions. You don't need to repeat yourself. It remembers context. It can respond differently depending on your location, time of day, or even your routine. The interface feels calm, patient, and almost like a companion who quietly understands your needs. Gestures continue to evolve alongside AI. Multi-finger swipes, pressure-sensitive touches, and context-aware inputs are now standard. The OS interprets them gracefully, reducing errors and increasing efficiency. You barely notice, but everything feels smoother, faster, and more responsive. Let's glide into predictive resource management. AI-driven OSs anticipate which applications you'll use next. They allocate memory, CPU, and storage ahead of time. Background processes are queued intelligently. Energy usage is optimized dynamically. The system feels effortless, responsive, and calm. Users enjoy multitasking without thinking about hardware limits. Everything runs seamlessly yet quietly. The OS becomes an invisible choreographer balancing complex demands silently. Cloud integration deepens even further. Files, apps, and media are available before you request them. Predictive syncing ensures that your workflow never stalls. Your devices communicate intelligently, deciding what data to store locally and what to fetch from the cloud. The OS quietly makes these decisions, keeping interruptions minimal. Security grows smarter too. AI monitors for anomalies in usage patterns. Potential threats are flagged before they affect the user. Permissions adjust contextually. Everything is handled seamlessly, allowing users to trust their devices without worry. Accessibility is enhanced in quiet and almost unnoticed ways. The OS can read documents aloud, describe images, suggest actions, and adapt input methods for users with varying needs. It learns which features are most useful to each individual and adjusts accordingly. Users feel supported without being overwhelmed. Let's drift toward personalization. The operating system adapts to routines, time zones, and even moods inferred from usage patterns. It adjusts brightness, color temperature, and notification timing. The OS shapes your experience subtly, creating a calm, predictable environment. Even small details matter. Icons adjust, gestures remain intuitive, and transitions are fluid. Everything is designed to minimize friction. The system stays patient, unobtrusive, and supportive. Now let's consider emerging paradigms. AI-first interfaces, Augmented reality and fully immersive AI promised to blur the lines further,